Hello, we are team number 1 and we are going to talk about the PIA presentation, and that is called the surface and coefficient of friction. Our team is constituted by 6 persons, that is Sofía Álvarez, Fabiola Gloria, Miranda Cos, and David Sanchez, Juan Santiago, and Mauricio Garcia. Okay, to get into a context, the Boston Marathon is a demanding test of athletic ability and physics, just as always is involved there. Wheel running or walking forward selection represents a crucial factor for optimal performance. This PIA project focuses on an experiment that investigates the relationship between shoe sole material and its impact on friction, a force that opposes slippage between two surfaces. Friction is quantified by a dimensionless value called the coefficient of friction, M, related with the frictional force, F, acting between two surfaces in contact, and the normal force, N, pressing the surface together. The coefficient of friction, as mentioned in the support TikTok video, is not only related to the resistance to slippage, but change from one type of shoe to another and is also affected by the surface conditions.
The theoretical framework. Introduction. In this experiment, we will test friction. We will be able to see how different our coefficients of friction are compared to those searched on the internet, in addition to being able to observe when greater or lesser friction is generated, with what type of sole and on what type of surface. All this in order to be able to experiment with friction. Key concepts. Friction. It is a force existing between two surfaces that are in contact and that opposes movement. That is, it has the opposite direction to movement. Coefficient of friction. The coefficient of friction is the ratio of the sliding force to the holding force exerted by two surfaces in contact. Factors influencing friction that are the addition between body surface, roughness of the surface, and the formation of bodies. The variables. Independent variable are the floor and the shoes. The dependent variable is the angle at which the shoe falls, and the controlled variable are the condition of the floor, is where it is wet or not, and the repetitions. The coefficient of friction. Wooden board, dry, 0.2 to 0.5, and wet, 0.5 to 0.9. And of the blank word, dry, 1.35, and wet, 0.3. That is of internet.
Did you know that the grip of your sneakers on the ground depends on something called the coefficient of friction? Today I will explain it to you in a super simple way. For a school project, I saw a TikTok that caught my attention on this project topic, in which they explained that in the Boston Marathon, Eliud Kipchoge, who is literally the best runner in the world, did not win the race. And we think it could be for several reasons, but one important one is that the floor was wet. That totally changed how the shoes grip the ground. When we run, the idea is that the shoes makes good contact with the floor. That is, that it does not slip at all. This happens thanks to something called friction force, which is basically the resistance between the shoes and the ground so that it does not slide. That friction force depends on a coefficient of friction, which sounds super technical, but it is just how the material of the sole of the shoes and the material of the floor interact. The problem is that when the floor is wet, that coefficient drops a lot. If it drops, there is less friction, which means that you cannot push off the ground as well, and then you lose power when moving forward. Oh, and something interesting is that not all shoes react the same to a wet surface. It depends a lot on the sole. Some are more slippery than others, so then that may have affected Kipchoge as well. Now let's go with the experiment. Notice how some sneakers have more grip than others, all because of the material of the sole. This affects the force of friction, which is key to running or walking without slipping. For example, on the dry board, the one with the highest average angle was the non-slip shoes, and the one with the lowest were the running shoes. This means that the ones with the highest coefficient of friction were the non-slip shoes. Y no en el 20. En el 30. Hola. 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 On the dry board, the one with the highest average angle was the Puma sneakers, that is, with a higher coefficient of friction. O sea, ni el profe en el PIA. Ya tengo. Y eso que no usa espejo. La toma. Y el TikTok sigue. Primera toma del zapato de Mau. Evidencia de poniendo agua. Guácala. But on the wet board, the one with the highest coefficient of friction on average were the running shoes. Me está temblando ahorita la mano. 50. Hola. 60. Hola. 55. And as for the wet board, the one with the highest coefficient of friction was the Crocs. Perhaps for this reason, people shower with flip flops because they are less likely to slip. So the next time you choose sneakers, think about where you will wear them. The coefficient of friction can make a difference.
Well, basically, as we can see here in the first table, in this table we placed the shoe on a wooden surface, and we can see that when the table got a with greater degree of inclination was achieved, and we can also see the different values of the coefficient of friction that we calculate. Here, in the following table, we can see that in the table of the whiteboard, in this greater degree of inclination was achieved, in all the shoes, and we can when the board is was really seen that degree of inclination rose too much in case of the tennis. In this we reached up to 70 degrees of inclination, it was too much. Thanks to all factors that we present.
Hello, I am Jose David Sanchez Garcia, and I have to tell you something. Here we have the results of all the coefficient of friction that we were able to obtain. Okay, here and the highest on the dry board were the platform tennis shoes, and on the wet board the running shoes. Okay, and here we have their shoes in on the platform of wood, and on the dry wooden floor the highest were the non-slip shoes, and on the wet wood were the crocs. And this is all for me. Thank you.
Hi, my name is Hanna Fabiola Gloria Gonzalez,
And my name is Juan Carlos Santiago Martinez.
and we make the discussion for this PIA. And for this little experiment, we decided to use different type of tennis, shoes, and flip-flops. Clearly, the friction of each one will vary because although they are the same concept, the friction can be really different, especially because they do not always have the same materials or the same amount of uses. We have to remember that friction is usually constant when walking, and depending on how many times and where we have used them, the friction force will change a lot.
This also happened with the superface we are testing. As we choose the superface is also key in determining the friction force. If the surface is rough, such a wooden board, it might have a higher friction force than a smoother surface such as blackboard.
It is also important to mention that water can really change the friction of things, since it is usually easier to slip on a wet surface or one that is greased with oil.
Taking these factors into account, we were able to obtain satisfactory results thanks to our previous knowledge of the subject.
The coefficient of friction is present in every moment of our lives. Thanks to this work, we learned that it can really influence daily life activities such as running or walking. We understood that this coefficient will depend on the type of sole and the type of surface, and that it can change if the surface is dry or wet. We do not realize that such simple things that we commonly do, like choosing what shoes to wear, can define our day. Now, we know when it is better to wear a certain type of shoes, and we realized that sometimes stores can scam us by telling us that they are non-slip shoes. It is best to try them on first in case of any accident. So, next time you choose our sneakers or shoes for the day, it is not just about how they look, but also how they behave in the conditions where you will use them. Thank you. And this is the reference of our PIA presentation. And thank you for watching our presentation. See you soon.